Water Quality Metrics by Nicole Jones. Surface water pollution comes from point and non-point sources. Point sources are pollution where the specific point of pollution where the pollution is entering into the waterway can be identified. Some examples of this are sewage treatment plants or industrial activities. Non-point sources are when there is not one specific point, but it's more diffuse over an area. Some examples of that would be runoff from urban areas, stormwater runoff, or agricultural activities where there's runoff from feedlots or agricultural land. Surface water pollution can also occur naturally from chemicals and compounds that naturally occur in the environment. Examples like pollution. Healthy water equals healthy ecosystems. Ecosystems are a balanced environment where organisms depend on each other to keep that balance. When one element becomes unbalanced, then it can cause the ecosystem to collapse, which can result in the loss of biodiversity in that ecosystem. So unclean water is one factor that can upset that ecosystem. Unclean water also leads to disease and death of humans, as well as it can be associated with reduced recreational usage and poorer quality of life for people. It's important and necessary to study water quality for human use and biodiversity to make sure that we're still meeting those standards that are needed for so that humans can use the water to drink and bathe and perform activities of daily living, as well as to maintain biodiversity. Water pollution can cause diseases, it can cause eutrophication, which can reduce water. Introduction of foreign materials and chemicals in the water can affect plants and animals and be toxic to them. Bioaccumulation can occur where the compounds or contaminants are entering into the food chain and then traveling up the food chain. Death and loss of species can occur when that any sort of imbalance in any of the water metrics occurs, like oxygen or temperature. Water scarcity can occur from water pollution, which can increase the cost of water, as well as increase the need for water purification or desalination if there's need for that from ocean water. Standards are important. Water quality standards are set by the EPA. It does this to maintain those levels of clean water, and those specific metrics are used to calculate the quality of health so that plants and animals that live in the water can maintain their healthy living conditions, and the people in the community can use that water for drinking and activities of daily living. The EPA metrics for healthy water is a pH between 6.5 and 9. Turbidity should be below 1 NTU. Dissolved oxygen should be about 6.5 to 8 milligrams per liter for cold water fish. It's a little different for warm water fish, a little different criteria. But for Sacramento, we're using the cold water. Specific conductance is less than 1,000 microsiemens per centimeter. It's preferred 150 to 500 microsiemens per centimeter is best to support fish. Temperature should not exceed 68 degrees Fahrenheit generally. However, in Sacramento, it's a little more stringent. I believe it's 56.3 because salmon cannot tolerate the warmer water. The metrics used in this study are the pH, the turbidity, dissolved oxygen, specific conductance, and temperature. The explanations of the metrics are that the pH tells how acidic or basic the water is. Acidic water reduces the oxygen level. It's not healthy for aquatic life or human consumption. Also, heavy metals are found in acidic water, which can lead to negative health effects. The turbidity shows the suspended particles of water. High turbidity indicates that particles have been picked up or washed into the water from sources like ash, silt, inorganic or organic matter, algae, clay, dissolved compounds. Stormwater runoff, erosion, as well as algae blooms are a source of that high turbidity. Temperature determines the health of the water for organisms that need specific temperature parameters to survive. Lower temperatures can hold more oxygen, which is healthier for fish and other aquatic organisms. So you really like that lower temperature. This also affects the dissolved oxygen in levels in the water, and that indicates the amount of oxygen is available to the organisms that live in the water, like the plants and the fish. And then the last one is specific conductance, and this measures the measure of the ionic content of the water. So when there is high dissolved solids in the water, that contributes to high specific conductance. So when compounds are dissolved in the water, their negative or positive ions are dispersed into the water. And so high specific conductance means that there's a high level of ions that are dissolved in the water, which can be from unhealthy compounds or chemicals. So dissolved oxygen, the numbers that I got, so the mean number of the mean amounts for the past 30 days of dissolved oxygen in this area of the Sacramento River was 9.98 milligrams per liter. And so that shows that this exceeds the level set by the EPA. This is the USGS's time graph, and this is mine. It's very similar, so it's very cool to see the similarity. The temperature was 13.5. It's at 56.3 Fahrenheit. So it is within the standards, and it does meet the standards for Sacramento standards because they are a little different because of the salmon. And the time series graph is similar. There's mine. Specific conductance was 133 microsiemens, so that is below the limit, indicating compliance with the regulation. And very similar, like seeing little peaks and stuff. Turbidity was 2.96. It is below that 5 NTU, but not below the 1 U. So it falls within the standards. However, it's not within the best parameters. There is a little outlier there, a couple of them that might have, skewed that a little bit. And there's mine. The pH is 7.6, well within the standards, which is great. And there's my time series graph. The data altogether shows that this area meets the EPA standards. So the application of the Safe Water Drinking Act. The Safe Water Drinking Act protects this water in that it enables the EPA to set standards for the pollutants in the drinking water that are naturally occurring, as well as the man-made pollutants. The procedures, it also outlines the procedures for monitoring and maintaining the water. So it applies to the public water system. It specifies the contaminants. It also specifies maximum amounts, as well as it determines feasible methods to remediate any sort of contaminant if it goes beyond the limits that are set. And the application of the Clean Water Act also protects this water in this watershed by setting the standards for the regulation enforcement that restricts the discharge of pollution into the watershed. So it accomplishes its goals by prohibiting the discharge of pollution in water, authorizing the EPA to set and maintain standards, as well as requiring permits for discharging of pollutions as a way to monitor and control pollution, as well as provides funding for sewage treatment plants and planning to clean and restore polluted waters, as well as continue to manage point and non-point pollution. So these are my references. Thank you very much.